Hey folks, here's the video for the grade 9 applied for ratios. I'm going to go through a number of different examples, and after each set of examples there will be some practice questions that are on the homework assignment for the ratios unit. So I would stop the video when you get to that part and then go off and try the homework questions and then go back to the video and watch the next piece. So you've probably seen a ratio as a comparison of two different amounts. So this example says that the number of students to computers at this school or in a class is 5 to 1. That means that there's 5 students for every 1 computer. And that's kind of a picture of that, but that doesn't necessarily mean that there's only 5 kids in the class. Probably there's not, right? We can make an equivalent ratio because maybe for each computer in the room there's 5 students, but maybe there's 6 computers in the room. That would mean that there's 5 times as many students as computers. So here there would be 5 and 5 and 5 and 5 and 5 and 5. So 30 students, because this 30 students for 6 computers is an equivalent ratio to the 5 students for 1 computer. So we want to be able to determine what equivalent ratios are, and typically we do that either by multiplying or dividing. So different ways to write ratios. This first ratio is 8 to 10, and you can multiply both of these by 3 and get an equivalent ratio, which is 24 to 30. So multiplying the 10 by 3 and multiplying the 8 by 3, we get an equivalent ratio. We can also write ratios in fractions, because the ratio of 8 to 10 is sort of the same as the fraction 8 over 10. And then we can multiply the tops and bottoms of that by the same value and get 24 to 30 in a fraction, that those would be equal. So we're going to do an example here. The first one, we're going to determine equivalent ratios by multiplying. So here, just to kind of show back on the same thing, we're going to pick any number. I could multiply this by 3, but I could also multiply it by 5 or by 2, anything you want. So I'm going to pick any number to multiply, but it has to be the same to both. So maybe for this one, I'll pick times 3 and times 3. So that my new equivalent ratio, on the left I would do 2 times 3 is 6, and on the right I do 5 times 3, which is 15. And the next ratio here is 7 to 3. So I'm going to multiply by something different. I might multiply here by 5, but you guys could pick something totally different. You could pick multiply by 8 or by 17 or anything. So 7 times 5 gives me 35, and 3 times 5 gives me 15. And those would be equivalent ratios to the ones that you started with. When you're dividing to get equivalent ratios, it's a little bit more particular. You won't likely want to divide by something that's going to give you messy decimals, though you could. So here I have 20 to 30. I see right away those both end in a 0, so I could divide both of these by 10. So I'm going to do divided by 10. So here, 20 to 30, 20 divided by 10 is 2, and 30 divided by 10 is 3. So that's an equivalent ratio. 9 and 12, what could I divide those both by? What number could I divide them by? I could divide those by 3. Both 9 and 12 can be divided by 3. I don't want to pick something that's going to give me a messy answer. So 9 divided by 3 is 3, and 12 divided by 3 is 4. The next one, 16 to 32. Lots of different numbers actually can get divided here. I might pick 2, just a nice small number. So here, 16 divided by 2 is 8, and 32 divided by 2 is 16. So one thing you might notice is that I could also do more division on this. I could divide maybe both by 4 or both by 8. These ones, the first two, I've divided by something where I can't keep dividing anymore without getting decimals. So these ones would be in what's called lowest terms. And this one would not be. This is not lowest terms. You could keep dividing. But it didn't ask me to get it into lowest terms, so I might leave it like that. So that's the end of the first set of questions. You guys are going to stop the video now and do these practice questions. They're also on the Ratios Practice Google Doc. If you've printed that off or if you have that open, you're going to complete these 3 questions with 4 parts each and write equivalent ratios. For the last one, you're finding 2 equivalent ratios. So you might do one by multiplying, one by dividing. You might do both by multiplying or both by dividing. Whichever it is, you'd want to find 2 different ratios. So once you finish that, we can move on. And we're going to move on to solving proportions. So this is something what we're going to do to figure out a missing value in 2 equivalent ratios. So when I'm solving proportions, I really like to rewrite these, and I find that most people find this easier, to rewrite these as 2 fractions. And the first part of the ratio goes on top, and the second part of the ratio goes on the bottom. So the 5 goes on the top and the 60 goes on the bottom. Then the 35 goes on the top and the x goes on the bottom. So basically, I want to figure out what did I multiply by in the first ratio to get to the second ratio. So here, I went from 5 to 35. I got bigger, so I know I would have done a multiplication. And 5 going up to 35, that's times 7. So in the bottom, to figure out what x is, I would have to also do times 7. And just to kind of note, 60 times 7 is 420. So that means x equals 420. So I'm multiplying across there. The next one, we've got 6 over x equals 2 over 7. And I can look at this and say, what did I do to go from the 6 to the 2? That wasn't multiplying, because multiplying would make it bigger. This was division. And 6 divided by what equals 2? We know that's 3. Whoops. Actually, I'm pointing my arrow in the wrong way because now I have an x on the other side. I want to figure out what I'm doing to get to the x. So I'm going to point my arrows the opposite way. So what did I do to the 2 to get to 6? Not dividing now, actually times 3. So I have to do the same thing to the 7 to get to the x. So if I do 7 times 3, I get x equals 21. Setting up the next one, 4 over 9 equals x over 18. So I'm going to point my arrows to the x, and they have to go in the same direction. So from 9 to 18, what did I do to get from 9 to 18? I did times 2. So I have to do the same thing going from 4 to x. So 4 times 2, I get x equals 8. And the last one, 10 over 7 equals 5 over x. Now here, if I want to figure out how to get from the 7 to the x, I have to figure out what I did to get from 10 to 5. So going from 10 to 5, I'm dividing by 2. So I have to divide by 2 on the bottom as well. So then x is 7 divided by 2, so x is 3.5. We're going to look at another way of doing these. Sometimes we don't have a pattern with these that we might see going across. So 3 over 9 equals 4 over x. I make them into a fraction. And if I drew arrows here, can I say what I did to 3 to get to 4? What did you multiply 3 by to get to 4? I don't know. That doesn't work really well. So what I'm going to do is, instead of drawing my arrows from left to right, I'm going to draw them going down. I'm going to see, can I find a pattern that way to find out what my x is. And if you look at this arrow inside the ratio or within the ratio, what did you do to the 3 to get to 9? We know that that's times 3. So if you do the same thing to the 4, you're keeping it the same. 4 times 3 is 12, so x equals 12. Then we'll rewrite this. 5 over 20 is 7 over x. So here I don't have, across the ratios, I don't have a good pattern. I don't know between 5 and 7 what I'd be doing there. But I can look at within the ratio. What did you do to 5 to get to 20? You multiplied it by 4. So we can multiply the 7 by 4 as well. So x is 7 times 4, which is 28. So the next one, 5 over 10 equals x over 6, first one over the second one. And here, I always want to figure out how to get to x. So I'm going to draw my arrows going towards the x. That means the arrows have to go from the bottom to the top. So what did you do to 10 to get to 5? You didn't multiply, you divided by 2. So I have to do the same thing to the 6. And here I get x equals 3, because 5 over 10 is the same as 3 over 6. So the next practice, you've got 8 problems here. I want you to try these, and these will be submitted at the end of the assignment. You're going to multiply between ratios or divide to figure out the value of each variable. So pause the video, take the time to do this one from the worksheet, and then you'll continue on when you're ready to do the next assignment. So here, we're going to continue on. These are a little bit, some of these are a little bit mixed up. We want to figure out what we were doing to get kind of back and forth. So if I did to figure out how to get to the x this way, how did I get from 10 to x? I have to do the arrow the same way, going from 30 to 6. What did you do to the 30 to get to 6? You made it smaller, so it's dividing, and that's divided by 5. So I'd have to do the same divided by 5 up there. So x is 10 divided by 5, which is 2. And the next one, here you might see, I might do this one within the ratio. What did you do to the 3 to get to 1? You made it smaller, so it's divided by, and that would be divided by 3. So if I did 12 divided by 3, I get x equals 4. So these are the same as the ones that you should have just practiced. When you get to the last one, This is x over 5 equals 2 over 9. So I want to see if I can find a pattern between the two ratios. Is there a pattern that I can do between 5 and 9? There's not. I don't know 5 times anything equals 9. And it would be a messy decimal if we did. And what about 2 and 9? Can I do a pattern up and down like in this one with the 1 and the 3? I can't. So here we're going to have to learn a new skill called cross multiplying. And this means we're going to multiply on the diagonal. So what that means is that we're going to multiply across the equal sign, bottom to top. And I always do the multiplication with the x in it first. So going in this red one that I've highlighted in red, x times 9, that's 9x, equals, and then I would have the other multiplication, 5 times 2. So that's 10. Now I have to solve this equation for x, and the opposite operation of 9 times x is dividing by 9. So this one you do on your calculator, 10 divided by 9 is about 1.1 repeated. So that would be 1.1 repeated. So we're going to do a couple more examples of this. If we don't see a pattern, you have to use cross multiplication. Cross multiplication, if you like this way, it will actually always work, even for the ones where there is a pattern. So I'm always going to circle the diagonal that has the x in it first. So the first diagonal I do is x times 13 is 13x equals, and then the other diagonal is 2 times 10, so that's 20. Now I have to divide to get the x by itself. So here I get x is 20 divided by 13, and we would just round that to 2 decimal places. That's approximately 1.54. Next one, 5 over 7 equals x over 9. So I'm multiplying the diagonal with the x first. It doesn't matter like the one going up or the one going down. I always do the x one first. So I have 7 times x is 7x, and 5 times 9 is 45. Then I divide by 7 to get the x by itself. And you'll notice that lots of these are going to end up being decimals. If you can't see a pattern, it's probably because it's a decimal answer. And that one is about 6.43. And that's rounded off. Make sure you're rounding properly to 2 decimal places. So last example here, we've got x and a 2 on that diagonal, and 3 and 9 on this diagonal. So I get 2 times x equals 3 times 9 is 27. And then divide by 2 to get x by itself. We get x equals 13.5. So you won't always have to round it. That one was okay. So the third practice, again, I want you guys to pause this video, stop the video now, go do these questions, and check your answers. Make sure that you feel like you're confident in this before you move on to the next equations. So the last ones are word problems. So this one says, Kirsten's neighbor used 120 patio stones to cover 8 meters squared. Kirsten wants to build a patio using the same type of stone. Kirsten wants to pave 18 meters squared of her backyard. We can use unit rates to figure out the amount of patio stones. So we're going to find this using ratios. So the neighbor had a certain amount of stones that covered a certain amount of area. The neighbor used 120 patio stones to cover 8 meters. And we want this to be equal for Kirsten because she's using the same kind of stones. So what do we know and what do we not know? So the 120 is the patio stones. And this says determine the number of patio stones. So that's what we don't know. I'm going to put an X there. And we know that the neighbor covered 8 meters squared, which is area. And we know that Kirsten wants to do 18 meters squared. So this is our ratio that we're going to be working with. I'm going to rewrite this as 120 over 8 equals X over 18. So here, we could try and look for a pattern between here and here, or we could do the cross multiplying that we just talked about. I think I'm going to do cross multiplying. So I'm going to look at the one that has the X first. And this 8 times X would be 8X equals, and then I'll do the other diagonal, and I'll do 120 times 18 on my calculator. That's 2,160. Then I can get what X would equal by dividing by 8. So Kirsten would need 270 patio stones. If we have a word problem, we have to write a therefore statement. Therefore, Kirsten needs 270 patio stones. This one's kind of similar. We're going to have two parts here, A and B. So Imran is visiting his grandmother in the United States. He can exchange $20 Canadian for 17 US. So Canadian, that's a short form for Canadian dollars, and US dollars. So we know that 20 Canadian dollars is equivalent to 17 US dollars. So we want to know how many US dollars would Imran get if he changed 225 Canadian. So we know my ratio is 20 to 17, and that is going to be equal to, make sure you keep them in the same order here. So 20 Canadian, and then he has 225 Canadian. So that has to go in the first part of my ratio. So I'm going to put the 225 there. And the US dollars, just to kind of color code this, is 17. So the US dollars is in the second part. And this says how many? We don't know. I'm going to put an X. So here, if we make them into fractions, 20 over 17 equals 225 over X. Then we're going to do our cross multiplying. Multiplying the one with the X first, so I get 20X. And then I multiply the other diagonal. 225 times 17 is 3,825. And to get X by itself, we'll divide by 20. So that is $191.25. So therefore, he could get $191.25 in US. So the next one says when he returns, he has $10 US left. So I'm going to use this same ratio, the 20 to 17 that I had before. And I have to keep them in the same order, Canadian and US. So this one, the amount that he has left is US dollars now. So that 10 is going to go in the second spot. And I have to figure out what my Canadian dollars, that is my unknown. So I'm going to put an X in the first spot. And then I'll solve this ratio. So making them into fractions, 20 over 17 is X over 10. And multiplying diagonal, I have 17X equals 200. And divide to solve for X. So 200 over 17 is about 1176, 2 decimal places for money. So here I'd say, therefore, this is $11.76 Canadian. So the next practice, you've got a few questions here, 2 questions there, one about auto repairs and one about hockey, and then number 3, and then number 4. So all of these homework questions have to be completed, and once you're finished all of that, I would like you to submit your ratios work, and then we can schedule the ratios unit test.